Good evening student, welcome to Kukreja classes. In the previous section, we have studied about the resistance. Uh, Today we will build on that knowledge and learn about the series and parallel circuit of resistances. So starting with the resistance, it has been found by the experiment that the resistance of the conductor is directly proportional to its length, and second, the resistance of the conductor is inversely proportional to the area of cross section of the conductor. Combining these two, resistance of the conductor is proportional to L by A. And when we replace the proportionality sign with constant, which is called rho, it's a Greek letter rho, and rho is the specific resistance or the resistivity of the material of the conductor. The specific resistance of the material or the material of the substance depends upon the material of the substance, nature of the substance, and the temperature. We know that the resistance of the good conductors of electricity should be low, and the resistance of the bad poor conductors should be high. Will be high. We know that. So the specific alloy, if you know the alloy is a mixture of two or more metals or metal or a non-metal, which are made to improve the properties of the metal. So alloy has a more resistivity than as compared to the pure metals from which they are made. So if we take example of nichrome, which is an alloy of nickel, chromium, manganese, and iron, which has a resistivity 60 times more than that of copper. Similarly, other example is of manganese. So manganese is an alloy of manganese, nickel, and copper, which has a resistivity 25 times more than that of copper. The heating elements and the heating coils of the electrical heating appliance like electric heater, electric toasters are made up of high resistivity materials. And if we take example like nichrome, which is used as a heating element, has a very high resistivity. It does not undergo oxidation, means it does not burn on high heating. When it is red hot, it keeps red hot for a long time. So this way we use the nichrome in the as electrical coil or a heating coil in the heating electrical appliances. So do you have any question related to specific resistance? So please tell me so that we can move on. So students, now we will discuss the series and parallel circuit of resistors. So resistors can be combined or can be connected in two ways. One is series. In the series and one is parallel. When we want to increase the resistance of a circuit, we add the resistances in series, and when we want to decrease the resistance of the circuit, then we add the resistors in the parallel. In the series circuit, you can see here we join the resistors end to end consecutively, and in the parallel circuit we join the resistances between two same points A and B here, between 2 points. So this way we create the series and parallel circuits. In the series circuit, as I told you that if you want to increase the total resistance, or suppose you have a one resistance of 2 ohm and another is of 4 ohm, when they are connected in together in a series, the total resistance becomes 6 ohms, and it's a sum of total resistances. So the as per so when two resistances are connected in a series, so according to law of combination of resistance, the combined or resultant resistance of the circuit will be equal to the sum of the individual resistances joined in series. So this way the total resistance of the circuit get increased. So before deriving the formula for the resistance, for getting the resultant resistance of the resistors joined in series, we should know that there is a we should be aware of two facts, that there is a potential